Isaac Newton is one of the most significant figures in the history of science. Born on January 4th, 1643 in Woolsthorpe, England, his work laid the foundation for many scientific principles we rely on today. Newton's most famous work, Philosophiae Naturalis Principia Mathematica, published in 1687, introduced his laws of motion and universal gravitation. These principles revolutionized physics and had a profound impact on astronomy and engineering. His contributions to mathematics, particularly calculus, provided tools still in use today. Newton's legacy continues to inspire scientists and researchers around the globe. Isaac Newton's early life was marked by hardship. He was born prematurely and was not expected to survive. His father died before he was born, and his mother remarried, leaving young Newton in the care of his grandmother.
At the age of 12, I was sent to the King's School in Grantham, where I lived with an apothecary. Here, I developed a keen interest in chemistry. My school days were marked by curiosity and experiments.
In 1661, Newton entered Trinity College, Cambridge, where he studied modern philosophers like Descartes, Galileo, and Kepler. At Cambridge, Newton's genius began to flourish, leading to groundbreaking discoveries that changed the course of science and mathematics. During his time at Cambridge, Isaac Newton's brilliance started to shine through. In 1665, the Great Plague forced the university to close, and Newton returned to his family home in Woolsthorpe.
I used this time to develop my theories on calculus, optics, and the laws of motion and gravitation.
His work during the Plague years laid the groundwork for many of his later achievements. Upon returning to Cambridge in 1667, Newton was elected a Fellow of Trinity College. In 1669, at the young age of 26, he was appointed the Lucasian Professor of Mathematics. This role allowed him to further pursue his research and share his insights with the academic community. Newton's curiosity and determination to understand the natural world were limitless. One of Isaac Newton's most enduring contributions to mathematics is the development of calculus. Calculus is essential for understanding the physical world and is used in various fields, from engineering to economics. Newton began developing his ideas on calculus during the Plague years of 1665 to 1666.
At the same time, German mathematician Gottfried Wilhelm Leibniz, was independently developing similar ideas.
Despite the controversy, Newton's work on calculus was groundbreaking. He introduced the concept of derivatives and integrals, which are fundamental to the field. Calculus provided a powerful tool for solving problems related to motion and change. Today, calculus is taught in schools and universities worldwide, a testament to Newton's genius. Isaac Newton's laws of motion are some of the most important principles in physics.
Newton's first law of motion states that an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external force.
The second law of motion explains how the velocity of an object changes when it is subjected to an external force. It states that the acceleration of an object is directly proportional to the force acting on it and inversely proportional to its mass.
Newton's third law of motion is perhaps the most famous. It states that for every action, there is an equal and opposite reaction.
These laws of motion are fundamental to understanding how objects move and interact. Newton's ability to describe these principles mathematically revolutionized physics. Isaac Newton's theory of universal gravitation is one of his most famous discoveries. The story of Newton observing an apple falling from a tree is legendary, symbolizing his insight into the force that keeps us grounded on Earth. Newton formulated the law of universal gravitation in 1687. He proposed that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law of gravitation explained many phenomena, from the falling of an apple to the motion of planets and moons. Newton's theory of gravitation was groundbreaking. It explained why objects fall to the ground, how the moon orbits the Earth, and how planets orbit the sun. Newton's insights continue to influence scientific thought and research. Isaac Newton made substantial contributions to the field of optics.
In the 1660s, Newton conducted experiments with prisms. He discovered that white light is made up of different colors. When he passed white light through a prism, it split into a spectrum of colors, demonstrating that white light is a combination of all the colors of the rainbow.
Newton also studied the nature of light and proposed the particle theory of light.
In addition to his theoretical work, Newton made practical contributions to optics. He invented the reflecting telescope, which used mirrors instead of lenses to gather and focus light. Newton's work in optics was innovative and influential, with his discoveries about light and color being fundamental to our understanding of these phenomena.
One of Isaac Newton's most notable inventions is the reflecting telescope. This device was a significant improvement over the refracting telescopes of his time. Traditional telescopes used lenses to magnify distant objects, but these lenses had a significant drawback: chromatic aberration. In 1668, Newton built the first practical reflecting telescope. His design used a concave primary mirror to collect light and reflect it to a focal point. This design eliminated chromatic aberration and provided sharper images than traditional refracting telescopes. The reflecting telescope became the standard for astronomical observations. Newton's innovative design is still used today in modern telescopes, including large observatories and space telescopes like the Hubble Space Telescope. Isaac Newton's contributions to astronomy were profound. His laws of motion and universal gravitation provided a framework for understanding the motions of celestial bodies. Newton's work allowed astronomers to predict the behavior of planets, moons, and comets with remarkable accuracy.
Newton's work also explained the orbits of comets. He demonstrated that comets follow elliptical paths and are subject to the same gravitational forces as planets.
In addition to his theoretical work, Newton made practical contributions to astronomy. His invention of the reflecting telescope allowed for more precise observations of celestial bodies. Newton's influence on astronomy extended beyond his lifetime, laying the foundation for modern astronomy. Isaac Newton's impact on modern science is immense. His discoveries and theories laid the foundation for many scientific principles and advancements.
Newton's laws of motion and universal gravitation are fundamental to our understanding of the physical world.
His development of calculus provided essential tools for solving problems related to change and motion. In optics, Newton's discoveries about light and color changed the way we understand these phenomena. His reflecting telescope design is still used in modern telescopes. Newton's method of inquiry based on observation, experimentation, and mathematical analysis has become a cornerstone of the scientific method. Isaac Newton's legacy is one of unparalleled genius and lasting impact. Isaac Newton's contributions to science and mathematics have left an indelible mark on history. His discoveries and theories revolutionized our understanding of the natural world and laid the foundation for modern science. From his laws of motion and universal gravitation to his development of calculus, Newton's work has had a lasting impact. His pioneering research in optics and his invention of the reflecting telescope have changed the way we observe and understand light and celestial objects. Newton's influence on astronomy and his ability to explain the motions of celestial bodies have shaped the field for centuries. Newton's method of inquiry and his approach to understanding the natural world have become fundamental principles of the scientific method. Isaac Newton's genius and contributions to science and mathematics